Great day, learners. Good afternoon. It's me again, Miss Bethel. So this day, I am going to discuss about treatment in comparison. Specifically, we'll be discussing about HSD and LSD. So I know that there are a lot of comparison of treatment means that have been discussed in your lecture, but I just want to focus only or to give emphasis on these two treatment mean comparison. Okay? So let's start by having a glimpse of a specific experiment that was conducted. Actually, the reality is there are many ways to compare the means of the treatments tested in an experiment. Kunwari, you are actually doing an experiment wherein you have 10 treatments. And then in your ANOVA table, the treatment says that it's significant. So the question now is, what makes the treatment significant, or how significant or how different are each treatment from one another? What is the best treatment then? If it's significant, what is the most effective treatment that affects your response variable? So those are the things that we need to consider after doing our ANOVA or analysis of variance. Okay. So now, what should be examined? So first things first, consider an experiment wherein we are actually after of the rice weed control. So there is an experiment conducted in order to know what weed control strategy is very effective in rice fields. So this experiment is having 15 treatments. So the 15 treatments is actually divided into 4 techniques intended for hand reading. Tapos, 10 controls are actually using herbicides. It could be different brands of herbicides. So, kunwari, each brand represents one treatment. And one part of the rice field is intended for the control. When we say it's the control, it means po, wala po tayong ginagawang control or weed control management. So like, wala lang, pasagdaan lang tong area. Kung na ay rice field dito, kung na ay weeds magtubo, hayaan lang yung weeds na tumubo. So what are the probable questions that may be raised from this experiment? Again po, 15 po yung ating treatments. 4 po na specific treatments includes hand weeding. 10 po includes the use of different herbicides. Tapos isang control. So 4 plus 10, 14 plus 1, 15 treatments in totality. So the specific mean comparison that can provide these answers may be the following. For example, ito yung unang tanong. Is there any treatment effective in controlling the weeds? So to answer this, we need to compare the mean of the non-weeded treatment. Yung non-weeded po natin, yun yung ating control, with the mean of each of the 14 weed control treatments. Bali po, compute po natin yung mean ng ating control, tapos iisa-isahin po natin i-compute yung means din ng ibang 14 controls. Yung 4 po na nasa hand reading, at saka yung 10 po na the use of different herbicides. Okay? So another question is this. Are there differences between the 14 weed control treatments? So meron bang pagkakaiba yung 14 na yun? So if so, which is effective and which is not? So effective ba yung gumagamit ng herbicides or mas effective ba yung hand weeding? So we need to determine that. So among the effective treatments, kunwari may effective sa kanila, are there differences in levels of effectivity? If so, which is the best? So kung may differences po, kasi nga sinasabi ng ating ANOVA table na significantly different, so alin doon sa mga effective controls na yun ang pinaka-effective? Kasi siya yung nagbibigay, kunwari, effective in terms of murang lang yung herbicide, tapos yung spectrum niya, madami siyang napapatay na weeds. So, yung magiging grain yield mo ng palay ay mas madami in terms of kilograms per hectare. It could be in tons. Another question that you can answer is there a difference between the groups of hand weeding and the group of herbicide treatments? So pagka sinabing effective yung hand weeding, may effective sa kanila. Tapos meron ding effective sa herbicide. Meron bang pagkakaiba pagka sinabi natin ng ating weed control management ay hand weeding or herbicide? So yun yung ating dapat sagutin. So to do that, the means of the this should be 4 hand weeding treatments are average. So kung ano yung means ng 4, ito total, i-divide ng 4. And compared with the average of the 10 herbicide treatment. So, kukunin din po natin ang average ng ating 10 na treatments which includes the use of the herbicide. So, kung sino po yung mas malaki, yun yung masasabi natin na, tapos i-compare natin yung kanilang differences, so yun yung masasabi natin kung meron ba talagang significant difference or wala. So, another thing is this. Are there differences between the 4 hand weeding treatments? If so, which treatment is best? So, itong tanong naman pong ito is, sa 4, kunwari, yung 4 na hand weeding techniques na ginagamit, iba-iba. So, meron bang pagkakaiba sa kanila? Okay? If so, if meron po, which treatment is the best? So, to do this, the 4 hand weeding treatment means are compared to detect any significant difference among them, and the best treatments are identified. Another question is, are there differences among the 10 herbicide treatments? If so, which treatment is the best? Or which herbicide gave better performance than the 2,4-D treatment, which is currently the leading herbicide for rice? So to do this, we can actually do averaging or actually get the total and get the mean of those 10 herbicide treatments. In totality, the weed control experiment just tells us the diversity in the type of mean comparison. So, kahit pala sinasabi, kunwari, sa ating ANOVA table, nag-significantly different yung ating treatments. Meron pa ba palang pwede nating itanong? Kunwari, bakit sila significantly different? Paano kung i-compare natin yung ating mga 14 treatments sa ating control? Yun naman sa ating hand weeding, ano yung pinaka-effective? Doon naman sa pag-use natin ng 10 herbicides, ano yung pinaka-effective at saka least effective? So, para po atin yung masagot, we need to do treatment mean comparison. So, the different types can, however, be classified into either pair comparison or group comparison. Bali po, si LSD at saka si HSD are pair comparison. Pagka sinasabi po natin group comparison, kunwari, yun po yung orthogonal, pero yun po, hindi po natin i-discuss dito sa ating laboratory. Okay, so what are the two types of treatment mean comparison? We have pair comparison and or it could be the group comparison. I hope that's clear. So now let's focus on the treatment mean comparison. So these are readings from Gomez and Gomez, 1984, and Hoshman, 2006. So mean separation is actually a method of determining which treatment means are significantly different. And this could be classified again either as pair comparison or group comparison. Ang atin pong ipo-focus ngayon ay ang ating pair comparison. So, there are two types of pair comparison. We have planned pair comparison and unplanned pair comparison. For planned pair comparison po, kasi nga di ba, planado, there is a specific pair of treatments to be compared. And this was identified in advance. So, it could be comparing the treatment to a specific control. So, yun po yung ating planned pair comparison. kunwari yung ating example kanina na 15 treatments, tapos may isang control or no reading, tapos yung iba ay 14 treatments, merong 10 for herbicide at saka 4 for hand reading. So kung i-compare natin yung 14 doon po sa ating isang control, yan po ang sinasabi natin planned pair comparison. Pagka naman po unplanned pair comparison, there's no specific comparison chosen in advance. Okay? From the term planned and unplanned. So let's proceed now to LSD. Okay? Iba din po yung LSD sign. Yun po yung Latin square design. Pagka LSD, yun po yung tinatawag natin na least significant difference test. Okay? Accordingly, this is the simplest and most used test procedure. And a single LSD value is computed at a given level of significance. It could be at 5% or at 1% level of significance. And two treatments are declared significantly different if their difference exceeds the LSD value. Pakatandaan po natin, masasabi lang po natin na ang dalawang treatment ay significantly different, okay, if mas mataas yung difference nila kaysa sa ating LSD value. And another thing, this is most appropriate for planned pair comparison and valid for comparing all the possible pairs of treatment means. Only if the F-test is telling us na significant po. Okay? Pagka sinasabi doon sa ating ANOVA table na significant yung ating treatments, diba? Kung nag-CRD ka, diba? Treatment error total. Pagka yung treatment natin ay significant, so you could proceed with a certain comparison of treatment means. Kung nag-RCBD ka naman, RTET, replication, treatment error total. Kung nag-significant naman yung ating treatment or highly significant kunwari, so you could proceed again with a specific comparison of treatment means. The same din po sa ating LS design. Kung ang ating LS design ay, diba, row, column, treatment error total, kung significant naman po yung ating treatment, so go. You could proceed with comparison of treatment means. And another thing po, this is only limited if the number of treatments is not large, no? Dapat less than 6 lang po yung ating treatments para po mag-LS design. So, kunwari po yung ating example kanina ay 15 po yung ating treatments. Ibig sabihin, hindi po tayo pwedeng gumamit ng LSD doon para i-compare yung ating treatment means. And the number of possible pairs increases as the number of treatments increases. Kasi nga, di ba, pagka mas tumalaki yung ating treatments, pair po siya, pair comparison, planned pair comparison. So, ang ibig sabihin po, mas dumadami din yung ating pairs ng treatment. Kunwari, 5 po siya. So, treatment 1 versus treatment 2, treatment 1 versus treatment 3, treatment 1 versus treatment 4, treatment 1 versus treatment 5. So, i-compare naman po ang ating treatment 2 sa other treatments, treatment 3 po, 4, 5. Okay? So, mas madami yung ating treatments, mas dumadami yung possible pairs. Okay? So, 10 with 5 treatments. Bakit po naging 10? It's because, di ba, kung 5, so, it's like treatment 1. Compare mo doon sa 4. So, that's already treatment 1 and treatment 2, treatment 1 and treatment 3, treatment 1 and treatment 4, treatment 1 and treatment 5. So, 4 na po yun. So, meron naman po tayong treatment 2. I-compare din po natin ang treatment 2 sa treatment 3. So, treatment 2 sa treatment 4 at saka sa treatment 5. So, 3 na po yun. So, 4 plus 3, it's 7. So, i-compare naman po yung ating treatment 3 kay treatment 4 at saka kay treatment 5. So, that's 2. So, 9 na po yan. Okay? Tapos, yung huli po, i-compare natin sa treatment 4 kay treatment 5 plus 1. Kaya po, 10 possible pairs of treatment. So, that's around 29%. And 45 with 10 treatments, 105 with 15 treatments. So, tignan po natin, no? Mas lumalaki po yung ating percentages. Kaya po, mas mainam na yung ating gamitin ay less than 6 treatments. Kasi po, 29% lang po yung ating possible na i-expect. So, I hope po yan po ay clear sa inyo. Okay? So, let's try to beat the clock, no, and discuss LSD in a nutshell. So, first is we are going to be familiar or be acquainted with the formula, okay, of the LSD, using a specific alpha. Okay, so the T alpha, it could be 5% or at 1%, depende kung saan siya nag-significant. The DF error multiplied by the ST or standard error of the mean difference. So TA is the tabular value at alpha level of significance and with N or the error degree of freedom from the table of the distribution of the probability or appendix C of Gomez and Gomez. And ST again is the standard error of the mean difference. Again po yung alpha po natin gagamitin kung saan po siya nag-significant. Sa 5% ba or sa 1%. And to compute for the ST, we need to use the square root of 2 times the variance or simply the MSE of the ANOVA divided by the R or the replication. So, this is actually a specific formula for a complete block design kagaya po ng ating CRD, RCBD, or LS design. Meaning po, meron lang po one error term na na-involve. Pero, pwede din pong SD is equals to square root of 2 MSE over R. Kasi po, yung ating variance, itong S squared na ito, saan ba ito? Ito. Okay? This is just the MSE or the mean square of the error in our ANOVA table for equal replication po. Pero kung meron po tayong problem data, di ba, meron namang mga cases wherein unequal yung replication. Kunwari sa CRD. So we are actually referring to problem data. We could use po square root of MSE times 1 over kung ilan na lang ba yung natira ng rep 1. Kunwari yung rep 1, 4 pa. Plus 1 over, kunwari yung natira ng rep 2 ay 2 na lang o 3 na lang. Okay, this is for unequal replication. But don't you worry, in your exam, we will just be dealing with equal replication. Hindi po namin kayo papahirapan. Again, just be mindful kasi naman po ANOVA table yung ating titignan. Ito po yung formula na ating gugustuhin matutunan. Square root of 2 MSE over R para po makomplete yung ating standard error of the mean difference. Tapos, i-multiply po natin siya sa value, no, ng ating T alpha at saka DF error na makukuha natin sa ating table. Okay, para makuha yung ating specific LSD value. So, for the standard error of the mean difference naman, ito yung sinasabi ko kanina, this is just a repetition for a complete block design where one error term is involved. Use this one. Okay, ito po. Or, ito. Ito pala. Okay, this one. Pero kung unequal, ito yung ating gagamitin. Okay? So, be familiar with square root of 2 MSE over R para makuha yung ating standard error of the mean difference. So, for LSD, kunwari, let's have our null and alternative hypothesis. So, our null hypothesis tells us that treatment mean of treatment 1 is equal to the treatment mean of the second treatment. So, there's no difference between the effects of two treatments. Yung atin namang alternative is the treatment mean of the first treatment is not equal to the treatment or the mean rather of the second treatment. So, there is a difference between the effects of the two treatments. So, what's our decision rule? Po, do not reject our null hypothesis if the difference, no, ng dalawang treatment means ay mas maliit sa ating computed LSD value. So, yung ating interpretation nito ay non-significant. Kunwari, meron kang dalawang treatment na kino-compare. So, the absolute value po, ito po yung ibig sabihin ng dalawang bar. So, T1 minus T2, absolute value, if mas maliit ka sa ating computed LSD, so we need to accept our null hypothesis na wala po talaga silang pinagkaiba. Same lang yung effect ng dalawang treatment na yun. And we need to reject our null hypothesis and accept our alternative hypothesis if ang difference po ng dalawang treatment means ay mas malaki sa ating computed na LSD value. So, ang ating interpretation, meron po siyang asterisk kasi po siya ay significant. Ibig sabihin, magkaiba po yung ating dalawang treatments na kino-compare. So, let's have a sample calculation in LSD or our least significant differences. Bali po, okay, mali lang po itong pagkasulat ko. Hindi po to LSD sign. Kasi po, okay, parang inaantok ako nung sinulat ko to. ANOVA po natin ay sa CRD, hindi po siya LSD sign. Okay, so LSD po ito na least significant difference. Paki-correct na lang po, okay? So pagka sinabi natin CRD, di ba, meron na tayong TET na source of variation, treatment error, total. Okay, so given na po yung ating DF, yung ating SS, yung ating mean square, yung ating F computed, tapos yung F tabulated natin sa 5% at 1%. Definitely po ito ay highly significant kasi mas malaki yung value ng ating F computed sa ating F tab at 1%. So automatically, highly significant. Kasi po nag-highly significant siya. So pwede po nating i-compare yung ating data using LSD or least significant differences. Okay. So, with this one, we need to get first that tabular, okay, the value, okay, the value, this one. Kailangan muna natin kunin ang ating tabular T value at alpha 1% using a specific DF, okay, of the error. So, gagamitin po natin yung ating table. So, ang ating pong gagamitin ay 5% at saka 1%. Diba, ma'am? Highly significant siya. So, kailangan bang gamitin yung 5%? Yes. Kasi nga, di ba, mas mataas siya sa 1. So, automatically included yung 5%. So, yung ating value po at 5%, no, tabular value. Tapos, yung ating DF po ng error ay 32 ay 2.041. Pagka 1% naman po, it's 2.741. So, dito po yun. So, hanapin lang po natin. 5%, ito po yung gamitin natin. Kasi two-sided po, no? 5% at saka 1%. So, it's 2.04. Dito po sa table na to, kasi 30 lang po, wala po siyang, diretso po siyang 35. Pero kung isi-search po siya, using another table, no, na may 32. So, hindi naman po masyadong malayo yung 2.04 at saka 2.75 sa ating written value here, which is 2.041 at saka 2.741. You can research this. This is a verified value. And then, we are going to multiply this to the square root of 2 times the mean square of the error divided by our replication. So, 0.61 po ay nakuha natin sa ating mean square ng error. 5 po kasi meron po tayong 5 replication sa ating data. Paano po ba yan nalalaman na 5? It's actually given. Or given po na 5 or pwedeng pinakita po sa inyo na meron talagang 5 replications at saka kayo yung mag-identify. So, if you're going to get the value of this equation, this is equivalent to 1 at 5% ha. Tapos, pagka LSD naman, 1%. So, 2.741 times square root of 2 times 0.61 divided by 5. The answer is 1.35. Okay. So, lipali po sa exam po ninyong given na po yung ating table or talagang given na yung values. Okay. Isa-substitute na lang. So, we have here, di ba, yung sabi kanina, 2, 4, 6, 7. Plus 1, which is the control. So, meron po tayong 8 treatments. So, ranging from letters A to G and H is the control. Again po, 5%, kanina, di ba, yung values natin? 1. No? Ito po, 1. At 1%, it's 1.35. Ano po yung sabi kanina sa ating decision rule? Okay. Pagka po, it's less than the LSD value at a specific alpha level, not significant. Pagka greater than po, it's significant. So, tapos na po tayo sa ating step 1. Yung ating step 1 po is i-compute yung ating LSD value. Tapos, para ma-compute po yun, i-compute po muna natin yung standard error of the difference of the means. I-multiply po natin sa ating specific tabular t-value, including a specific DF, which is the error. Pagka nakuha na po natin yun, depende kung saan siya nag-significant at 5% ba or 1%. Pagka 1%, automatically i-include natin yung 5%. Pero kung nag-significant lang siya sa 5%, then, no, 5% lang po na at T, alpha yung ating, alpha ng LSD ang ating gagamitin. Okay, so ito po ay given na rin po. Bago yung makompute ang ANOVA, i-compute nyo po muna yung means ng bawat treatment. This is in kilogram. So get the difference from the control, absolute values po. So it's just 4.94 minus 4.3. So it's 0.64. For letter B naman, it's 5.02 minus 4.3, it's 0.72. So, for treatment C, it's 6.58 minus the control. Always po siya sa control, 4.3, the answer is 2.28. For treatment D, it's 5.24 minus 4.3, it's 0.94. And for treatment E, it's 4.44 minus 4.3, so it's 0.40. And 6.54 minus 4.3, it's 2.24. 5.18 minus 4.3, it's 0.88. So, ngayon po, mayroon na po tayong difference from the control. We need to interpret. Okay, ano po yung sabi natin kanina? Mas maliit sa LSD value, we are going to put NS. Pagka NS po, ibig sabihin, we are going to accept our null hypothesis na wala pong pinagkaiba yung dalawang treatment means. Pagka mas malaki po sa ating LSD value, ibig sabihin, significant po. Pagka po significant, ibig sabihin po, we need to reject our null hypothesis and accept our alternative hypothesis. So, ang 0.64 po ay mas maliit kaysa 1. Kaya po non-significant. Ang 0.72 din po ay mas maliit kaysa 1. Kahit hindi na po natin tingnan, no? Kasi mas malaki naman yung value ng ating at 1%. So, it's actually not significant. Ang 2.28 po ay mas malaki sa 1 at mas lalong malaki kaysa 1.35. Kaya po highly significant or significant to be more specific. Ang 0.94 po ay mas maliit kaysa 1 kaya po non-significant. Ang 0.14 ay lalong mas maliit kaysa 1 kaya non-significant. Ang 2.24 po ay mas malaki sa 1.35 at mas lalong malaki kaysa 1 kaya po significant. 0.88 po ay mas maliit kaysa 1, kaya po not significant. Ibig sabihin po, para mas lalo natin ma-interpret, wala pong pinagkaiba ang treatment A sa ating control. Wala din pong pinagkaiba yung treatment B kaysa ating control. Meron pong malaking pinagkaiba yung treatment C sa ating control. Wala pong pinagkaiba si treatment D at treatment E sa ating control. Wala din pong pinagkaiba si treatment G sa ating control. Bali po, same lang po yung effects nila. Ano po ba dito sa mga treatments na ito? Different yung effects nila. Si treatment C po at saka si treatment F. Unique or significant po ang kanilang difference compared sa ating control, which is treatment H. Yun lang po. Ganun lang po kadali yung ating LSD. Bali po, alamin lang natin kung paano i-control yung standard error, no, of the difference of the mean. Kunin natin yung T alpha, kung saan siya nag-significant at 5% ba or at 1%. Automatically, pagka nag-significant siya at 1%, isama po natin sa 5%. Pero kung nag-significant lang siya at 5%, si 5% na po yung ating i-include. Tapos po, Pag nakuha natin yung LSD, value natin, kunin po natin yung differences ng means ng ating mga treatment. I-compare po natin siya sa control. Bali, each treatment against the control. Okay? Tapos, you need to interpret. Based po ng ating interpretation, basehan po is mas maliit kaysa ating LSD value, not significant. So, same lang sila ng effects. Tapos, pagka mas malaki siya, significant. So, different talaga yung kanilang effects ng dalawang treatment. So, ganun lang po kadali yung ating less significant difference. I hope meron po tayong natutunan. Thank you. The second treatment mean comparison test that I'm going to discuss is honesty significant difference test, or this is called the Chuki's W procedure. Okay. It considers the number of treatments in the experiments. So it only detects fewer differences compared to the least significant difference. And this is a compromise of the LSD and the Schiff's test. But I'll not be discussing Schiff's test since it was discussed already in your lecture. Again po, sinabi ko po kanina na dalawa lang po yung i-discuss ko, HSD at saka LSD. So it is needed, again, the same with LSD, after we complete an ANOVA in order to determine which groups differ from each other. So do not conduct a post hoc test unless you found an effect, or meaning, if i-reject po natin, di ba, yung null hypothesis, ibig sabihin, significantly different po yung ating experiment in the ANOVA problem. So if you fail to reject the null, meaning, then there are no differences to find. Kaya po, hindi na po tayo dapat gumawa ng post hoc test. At bakit po honestly? Kasi we are going to really investigate the specific differences of the treatment means. So with this, first thing is you need to be acquainted how to compute the HSD value. So to compute for this, we need to consider the Q table. So in determining the value in the Q table, we need to consider the alpha, okay, kung saan po siya nag-significantly different. The P po natin is the range of the compared means. And DF of the error. So the range po ng ating compared means, kung ilan po yung ating treatments. So yun po yung ating P. Okay. And the standard error of the mean. So after determining the value of Q, we need to multiply that by the standard error of the mean natin. Now, let's proceed with our decision rule. So first is, do not reject the null hypothesis if the difference between two means, treatment means to be more specific, is less than the HSD value. So our automatic interpretation for this is it's not significant. So another thing that we must put in mind is that treatment means whose differences are lesser than the computed HSD value are connected with line and are declared not significantly different from each other and assigned with similar letter. Later on, mas ma-visualize natin kung ano ba yung ibig sabihin ng paragraph na ito. So, if we do not reject the null hypothesis, ibig sabihin po, kailangan natin siyang i-accept. So, another statement here is that we need to accept the null hypothesis if the absolute value of the difference between mean 1 and mean 2 is less than the calculated HSD value. Hence, the two treatment means are not significantly different from each other. Okay? And we need to reject the null hypothesis or simply accept the alternative hypothesis if the treatment differences are greater than the computed HSD value. They are not connected with lines and are declared significantly different from each other, and again po, assigned with different letters. So, if we're going to accept the alternative hypothesis only if the absolute value of the difference between mean 1 and mean 2 is greater doble yung than, the calculated HSD value. Hence, the two treatment means are significantly different from each other. So, dapat po tayong magkaroon ng ating example. Let's have a null and alternative hypothesis. So, we have here, of course, no, it's null, it's equal. So, the treatment of the first mean is equal to the mean of, okay. So, we have here our null and alternative hypothesis. So, it tells us that the mean of the first treatment is just equal to the mean of the second treatment. So, there's no difference between the effects of two treatments. Yung atin namang alternative is that it's not equal. So, ang mean ng first treatment ay not equal sa mean ng second treatment. So, there is a, mali naman po ito, okay? Paki-delete na lang po ng no. There is a difference between the effects of the two treatments. Okay? So, let's have an actual thesis data of a student in our department. So, ito po yung study niya. Morphoagronomic characterization of 4 prosomylet, the panicomyliaceae, cultivars grown in MIS-1 condition. Yung treatments niya po, yun yung 4 na varieties or cultivars. Cultivars meaning cultivated varieties. So, kinuha ko po ito sa kanyang thesis book. So, galing sa appendix table 20, the green yield in kilograms per hectare of prosomylet cultivars grown under MIS-1 condition. So, meron po tayong tatlong replications, okay? So, kinuha po natin yung mean ng variety 1, mean ng variety 2, variety 3, at variety 4 in terms po ng grain yield. So, magagamit po natin ito para ma-compute natin yung HSD. Okay? So, ito po yung kayang ANOVA table. So, analysis of variance on grain yield of prosomylet cultivars grown in MIS-1 condition. So, meron po ditong RTET. Kaya masasabi natin yung kayang study, kayang experimental design ay, yes, it's RCBD. So, meron po itong values, okay. Sum of square means square F value. Tapos, maninotice nyo po ito, meron pong PR is greater than the F. Kasi po, ang kanyang ginamit ay software. Pag magte-thesis na po kayo, hindi niyo po kailangan gumamit ng manual talaga. Meron naman po mga available software like R program or packages, SPSS, MStat, okay? Meron din pong STAR para po ma-compute yung RCBD, no, na ANOVA or any kind of statistical, okay, analysis that you could actually use statistical softwares. Lalo na po pagka masyadong madaming treatments nyo. So, meron po mga available tools online. So, ito po, kinuha ko din po yung F tabulated at 1% at 5%. So, pagka 2 po yung replication at saka 6 yung error, ito po yung values ng F tab at 1 at 5%. Pagka po 3 for the treatments at saka 6 for the error, ito po yung mga values. So, maninotice po natin na at ang replication po natin ay hindi po sila, it's not significant kasi po mas maliit po siya sa 5%. Pero yung ating po treatment ay significant po. Hindi naman po siya highly significant kasi mas malaki siya sa 5%, pero mas maliit siya sa 9%. So, it's significant at 5% level of significance. So, let's try to assess po, paano po ba gagamitin itong PR is greater than F? Baka po maka-encounter kayo ng ganito. Actually, PR, close and open parenthesis is greater than F is just a p-value. It is the probability of observing F statistics greater than some value. Or in other way, it is simply a p-value. And if p-value is less than the given level of significance, we reject the null hypothesis. Kunwari po at 5%, okay? So, at 5%, ano po ba yung mas malaki? Yung 0.05 or yung 0.2466? Di ba po mas malaki yung 0.2466 kaysa 0.05? Kaya po, masasabi natin na hindi po siya significant. Okay? Saka lang po natin siya masasabi na significant at 5% or 1% pagka mas maliit yung value ng ating P. Okay? Pero dito po, 0.04 ay mas maliit kaysa 0.05. Kaya po, it's significant. Pero mas malaki naman po yung 0.04 kaysa 0.01. Kaya hindi natin sasabing highly significant. Bali, ang gagamitin natin dito pagka PR, close and open parenthesis, greater than F, or simply the p-value, i-compare po natin siya automatically sa 0.01 at saka sa 0.05. So, kung i-compare natin itong 0.2466 sa 0.01 at 0.05, mas malaki siya. Kaya po, we are going to accept the null hypothesis. There is no significant differences. Pero po, ang 0.04 ay mas maliit sa 0.05. Pero mas malaki naman siya sa 0.01. Kaya 1 asterisk lang po. Okay. So, it's significant. So, we need to reject the null hypothesis and accept the alternative hypothesis na meron po differences. Okay? Kasi alam kong kabalo na mo magamit kung significant pa siya, highly significant, or not significant kung F-tab. Pero paano pagka ang gatag sa inyo is skinny siya? How are you going to interpret the result? So ngayon, alam na natin na ito pala yung exact table. Pagka mag-resist tayo, nasa baba yung CV, kunwari. So, alam natin na significant siya at 5%. So, we could proceed with HSD. So, first step is compute for HSD value. To compute for the HSD value, we need to use this formula. Okay? We need to multiply the value of Q from the table to the standard error of the mean. To get to know kung ano ba yung value ng Q, kunin natin kung anong alpha level. Alam natin na significant siya at 5%. Kaya 5% yung ating gagamitin. Yung P naman natin, yun yung range ng compared means. Alam natin na meron tayong 4 na treatments. Diba? Yun yung ating, balikan natin ito. Variety 1 hanggang variety 4. Yun po yung ating treatments. Okay? Tapos, yung DF error po natin ay 6. So, kukunin po natin ang P ay 4, ang replication ay 4, at ang error DF ay 6. Yung MSE po natin ay 310,505.3164. Meron na po tayong needed mga values. So now, we need to compute for the standard error of the mean. So to do that, we just need to get square root of MSE over 4. Okay? 4 po, or simply DN. Or simply po, 310,505.3164 divided by 4. Okay? So, the answer is 278.6150. Ngayon po, kailangan nating malaman kung ano yung value ng ating Q. Alam natin ng ating P ay 4, ang ating error DF ay 6, at saka yung ating alpha level ay 5%. Kaya po, tignan natin, hanapin natin yung 5%. Ito po, 4 po yung ating number of means, kasi meron po tayong 4 treatments. Tapos, 6 po yung ating error DF. So, 4 at saka 6, it's 4.9. Yun po yung ating Q na i-multiply natin sa ating standard error. Okay, so to solve that, it's standard Q value times the standard error of the mean. So, the answer is 1,365.2135. So, now let's proceed to step 2. Since step 2, we just need to compare the treatment means. First thing is, we're going to arrange the treatment means from highest to lowest. So, in doing this, we need to check on the given. So, it's either po, diretsong binigay sa inyo yung mean or hindi po diretsong binigay. Pwede din pong itong replications 1, 2, at saka 3 po yung binigay sa inyo. Kayo pa po yung magto-total ng mean. Okay? So, swerte na po if binigay sa inyo yung mean. So, i-arrange natin. Yung pinakamalaki ay treatment 3 or variety 3, followed by treatment 2 or variety 2. Third is treatment 1 or variety 1, and treatment 4 or variety 4. Pagkatapos po natin i-arrange, i-compare po natin sila isa-isa, hindi po sa control. Sa LSD po, control po yung ginamit. Sa HSD, we need to compare all possible associations or pairs. So it's V3 versus V2 versus V1 versus V4. V2 versus V1, V2 versus V4, V1 versus V4. So, to compare po, V3 versus V2, so we need to subtract. Okay? 2,933.89 minus 2,728.04. Get the absolute value. It's 205.85. Kung ano po yung varieties or treatments, kasi dito ang treatment natin, variety, na ating kinumpare, yun po yung ating isa-subtract. Okay? So, V3, 2,933.89 minus V1, which is 2,201.8. The answer is 732.09. V3 versus V4. So, it's 2,933.89 minus 1,332.82. The answer is 1,601.07. So, V2 naman versus V1. The answer is 2,000. So, to solve for that, 2,728.04 minus 2,201.8. The answer is 526.24. And V2 versus V4, 2,728.04 minus 1,332.82. The answer is 1,395.22. And to compute for V1, the last one, versus V4, it's 2,201.8 minus 1,332.82. The answer is 868.98. So, ngayon po, tapos na po tayo. So, we need to get to know whether it's significant or non-significant. Diba po, sabi kanina, significant siya pagka mas malaki yung ating difference ng dalawang treatment needs compared sa ating HSD value. NS or non-significant if mas maliit po yung difference ng dalawang treatment needs compared sa ating HSD values. So, to compute for that, to interpret the results, we need to do this. V3 and V2, 205.85 is less than 1,365. It's NS. V3 versus V1, 732 is less than 1,365. Again, NS po siya. V3 versus V4, 1,601 is greater than 1,365. Kaya po significant. V2 versus V1, it's 526. It's again less than this value. So it's NS. V2 versus V4, it's 1,395. It's greater than 1,365. Kaya po significant. V1 versus V4, it's 868. Less than, which is less than 1,365. Kaya po NS siya. So ngayon po, interpret po yung natin result natin. So in interpreting, we need to use superscript letters in the Chukis test. So the highest value receives the letter A. Bali po, letter A, si treatment 3 or si V3 kasi siya po yung pinakamalaki. So letter A po siya. Means that of no significant difference receive the same letter. So to visualize this, we need to have this one. So, galing po dito, V3, V2, V1, at saka V4. Tignan po natin. Si V3 at saka si V2 ay NS, kaya po may linya. Dapat isa lang pong linya dito. Si V3 at saka si V1 ay NS din. Kaya po, galing sa V3 hanggang V1, straight po yung ating line. Si V2 at saka si V1 ay NS din. Kaya po, V2, V1, may isa, meron pong guhit, di ba po isa. Si V3 at V4 ay significant. Kaya po, meron po tayong V3 dito at V4. Kaya po, wala po silang line. At saka iba po sila ng letter kasi po significant sila. Si V2 at saka si V4 po ay significant. Kaya po, A din po si V2 at B si V4. Or hindi po sila isang line lang. Si V1 at V4 ay NS. Kaya po, meron po tayong line from V1 hanggang V4. Okay. So, for us to know kung ano yung letter assignment, di ba po ang sabi kanina, pagka straight line, the same letter. Kaya po, this is A and A. Ito po, A din po ba ito? Yes, meron din po itong A. Pero nag-overlap po si V1 at saka si V4. Kaya po, ang mangyayari, ito po ay AB at ito ay B. Let's try to verify. Ang sabi is significant, dapat magkaiba yung letra, V3 at V4. V3 ay A, V4 ay B. Tapos, V2 at V4 ay significant. V2 ay A, V4 ay B. Ganun lang po kadali ang ating checklist test. I hope po ma-perfect po natin ito sa ating final examination. Thank you and be deeply blessed. Okay, so I hope po ready na po kayo sa inyong final examination. But for that, kailangan po muna natin isulat sa ating table, di ba? Ang sabi, V1 ay AB, si V2 ay A, ito po, si V3 ay A, at saka si V4 ay B. So, pagka ganito po yung ating makikita, ibig sabihin that V2 and V4 ay significant kasi magkaiba sila ng letra. Si V3 at V4 ay significant din. Okay? Ganun lang po kadali. Thank you so